I'm Anil Kumar. Welcome to my videos. Now let us consider a case that I'm driving a car on Highway 427 and I spot a deer just about 20 meters away. What is going to happen? That is the question which we'll answer today. Of course, I'll apply the brakes and hope that the deer is saved. Will it happen or not? Let us see. So what is happening in this situation is, as soon as I spot a deer, I'll think, and that reaction will help me apply the brakes, and then the car will try to stop. It is possible that it may hit the deer. So what we are talking about here is something like this. So if I'm driving, then let us say this is the point where I spot that a deer is there on the road. Then I'll apply the brakes. But within that time, car is going to move some distance. And that distance is called reaction distance. Sometimes we also say it is thinking distance. More you think, more closer you are to the danger point. Now, the reaction is applying brakes. As soon as you apply brakes, the car is going to slow down and stop. But it is going to take some time. In that time, some distance will be covered. And that distance is called the braking distance. So this distance is braking distance. And finally, car comes to a stop. Now this total distance from the time when we spot a danger, apply brakes, and the car stops is called the stopping distance. The total, that is to say, when you add these two things, what you get is stopping distance. Now here we have a graph which is very close to a real life situation. So in this graph we have two curves. This dotted line shown here is representing the thinking or reaction distance. Let me write reaction distance here. And this solid line is stopping distance. That means both combined together, thinking distance and braking distance. So that is the stopping distance for us. So this graph represents reaction time or reaction distance and stopping distance. Units on the horizontal axis, we have speed in kilometers per hour, 50 kilometers per hour, 100 kilometers per hour, so on. And on the y-axis, we have distance in meters. Now let me explain both the graphs to you. The first one, the reaction distance, is kind of linear. Time it takes for you to think really is constant, but how much distance you travel depends on your speed. So thinking distance or reaction distance is proportional to speed. For example, if we consider 100 kilometers per hour as the speed, then that is the amount of distance you'll cover, which is almost 20 meters. So this is 20 meters. So if you are moving at 100 kilometers an hour, by the time you apply brakes, distance covered is 20 meters. That means in our example, when we started off with a deer 20 meters away, it is going to come to a tragic end, because by the time you apply brakes, you're going to hit the deer with the same speed, 100 kilometers per hour. Unbelievable. But that's what will happen. Well, let's move on. Now, let's say the deer is not there at 20 meters, but the actual distance is, let us say, 80 meters. Now, let's see if that works for us or not. So now we have applied the brakes. As soon we apply the brakes, because of the friction between the tires and the earth, car will stop, but again it will move some distance. This solid graph shows you the distance moved, which includes reaction time and the braking distance. So for 100 kilometers an hour, we can spot this point and we move. So the total distance moved, if you are moving at 100 kilometers an hour and if you spot danger, apply brakes, the stopping distance is 100 meters. So if the deer is 80 meters away, then also the possibility is that you will hit the deer if it hasn't moved out. Now, can you tell me what is the braking distance? Well, of course, braking distance in this particular case will be, let me calculate. How much? 100 is the total distance minus 20. So it gives us 80 meters is the braking distance. So if you are moving at 100 kilometers an hour, then according to this graph, reaction distance is 20 meters and stopping distance is total 100. So braking distance was 80 meters. That means on the road you'll find scratches and you can see skidding of the car for 80 meters. So that is how you can understand the situation. Now here is a question for you. Question is, what is the stopping distance, reaction distance and braking distance at 50 kilometers per hour and 100 kilometers per hour? Well, I've already answered 100 kilometers per hour as a practice. Try to figure out all these distances for 50 kilometers per hour and let me know if the deer was 40 meters away, will it be safe or not? I hope you enjoyed this video. Thank you and all the best.